Assalamualaikum warahmatullahi wabarakatuh. So guys, we continue our discussion on another example. As you can see here in this video, the pendulum is suspended from point O, yeah, somewhere here, and consists of two thin rods. First one O to A, eh, and rod OA, and another one rod BC. Having a weight of 50 Newton, determine the pendulum moment of inertia about an axis passing through the point O. First one, mass moment of inertia. Second one is you have to find the center, mass center of G. Okay. If you see this pendulum, this is a thin rod. If you compare to the table to the next to it, so it is similar to slender rod. So let's look closer. Alright, this is a slender rod. You have how many axes given here? You have Z, X, Y, X prime, Y prime. For this kind of shape, slender rod or plate, any symmetrical bodies, basically G is in the middle. It's G, middle. Alright, before we solve this problem, I just want to let you know, if you have this uh, first first road O to A, which is it has 1 meter, and of course G is in the middle. G doesn't matter you pin at O, you pin here or some, it doesn't matter as long as this is a road, regardless where it is pinned, but G is still in the middle. Okay, similar to road BC, G remain in the middle. G remains in the middle, but when you combine these two, you combine these two, okay, when you combine these two, of course the G is not, the G is changing. Since this one is a composite body, you have to determine by yourself where is the G, as asking asking in this question. All right, then I hope that you understand the one. Where is the G? Where is the G of each split root? Remain in the middle. But when it's combined, the G is somewhere else. Okay, you have to find it. Okay, now we go to solve this problem. Okay, all right, we solve this problem. Okay, as we did in the previous example, what we can do is we have to find I root part by part. As we did before, I this moment of inertia of this moment of inertia of whole, and then we deduct it. So for this problem, we have to add it. So we have to add it. So we have to find what is I mass moment of inertia for road OA, and then at, sorry, not at G, not at G, not in the middle of this road, at point O, because you can see that if you push this road, you push this two road and this composite body, what happens is it can swing either to the right or to the left, where the axis of rotation is at zero, passing through zero. Okay, so I O A at O is equal to 1. So you have to refer to this mass moment of inertia uh, diagram. So if you imagine that if it's rotate about z, uh, so means that it's rotate like this, like you having a pen and you rotate it, all right, and then now you have to tally to this kind of problems. Okay, looks like if you pin at O, and this is OA, when it swings to the right for about 45 degree, what happened is this is OA when it swings 45 degree. Can you imagine that? Eh? Can you compare to this table, the basic of mass moment of initial equation, where you can see that this axis at O, uh, what we call it, match with the axis in this uh, figures. If you choose Z, it doesn't match because this one rotate in this direction. Now you have to find the axis of rotation here where it matches with this kind of motion. Okay, so looks like you can choose either what. Okay. It's a point O, of course this point O. So you can imagine that this rod can rotate either above Y axis or either X axis. Eh? Correct? So this one, if it's rotate, if this thin rod rotate about X prime axis, what happen is it can, if we look from this side, this view, I draw it. Okay, look from this one Z, this one Z. Of course, this one Y prime, and we don't want to look over Y and X, and this is Z, this is Z prime. So if it's rotate about this X prime, so if you, it looks like this one rotate in this direction. When it's rotate 90 degrees, 45 degree to the left, it is like this, right? If it's rotate to the right for 45 degree, it will be like this, right? So this is similar to what happened to this road OA, correct? So you can choose I O A, okay, is equal to what? You can choose is equal to, if you refer to the figures I, x prime, which is 1 over 2 m L square. You got one. You got the answers, which is 1 over 2. M is m is 5 kilograms. 5 times L. L is given as 1 meter. 1 meter. You can get the answer is 2.1 kilogram meter square. You got the IOA. Now we have solved the first one. How about second one? The second one is, all right, I B C is what? Okay, I B C is what? So let's go to the next page. Okay, now you have to find I, again, I B C at O. Eh? So you can see that if this is my point O, this is my, let's say that this is my point. Where should I write it? This is point O, and this is point O, and then this is my road BC. If I just draw like a dash line here, all right. So we hide the OA first. If this one rotate about point O for 90 degree, So what happened? What's the position of BC? I can say that BC, if it's rotate 90 degree, in this direction, it can be like this. this is my point C, this is my point B. Correct? So if keep remain rotate for another 90 degree, what happen is so another 90 degree, correct? So this is a point B and this point C. So it remains similar if you rotate another 90 degree or another 270 degree or whatever. But the thing is, you can see that the axis of rotation is here. Eh? So can you, if you take these figures, can you compare this to this one? What is the what is the mass moment of inertia equation that match with this condition where where you have to use parallel axis theorem? You can use parallel axis theorem. So this one, you can see that this one is parallel, not parallel. It can match to this point, the middle point of this one. It is in line with this one. So in line with this one, okay, is is either x or y, x or y. But here x and y refer to the middle. Now we have to use the parallel axis theorem where point A is shifted from the middle to somewhere else, where the distance here, this one, you can see the middle, to point O is about 1 meter. About 1 meter. So means that instead of this is the axis of rotation, if shifted somewhere for 1 meter. So this is your new, which is this is O. You can see that axis where this is O, this is the axis of rotation. For this one, you can see that X is parallel to this one. That's why we call it parallel axis theorem. Okay, so you can see that this rigid body or cylinder rod is rotate. Now it's rotate about new axis where it cross point O. So what we can do is we can take I, B, C, O, parallel axis theorem. I, B, C at G plus M D square. So IBCG is what? G is in the middle. Okay. IBCG is IXX. IXX is 1 over 12 ml square. 1 over 12 ml square plus M. M. So M is mass of BC. Plus MD D square. Okay, is equal to 1 over 12. M is 5 kilograms. L is L of the BC, which is 1 meter. So and D, the distance from here to here, from here to here, a new one, 1 meters plus 5, 1 meter. So your answer here should be, if I'm not mistaken, okay, the answer is 5.4. Sorry, the answer is 5.4167. Alright, on the previous road OA, I got a mistake here. Here should be 1 over 3. 1 over 3. I thought that it was 1 over 2. So 1 over 3, and then the answer here is not 2.5. I'm sorry. The answer here should be 1.667 meter square. Okay. Alright. So now you have to combine these two mass moment of inertia, IBC at O and IOA at O. So I, we call it I pendulum. Pendulum is I O A O plus I B C O, which is 1.667 plus 5.167. All right. Then the answer is 7.0837. All right. If you refer in the textbook, because it use 50 Newton divided by 9.81 to find the mass. So I mean there's a bit a different, because in the textbooks it give you 7.22 kilogram meter square. Okay? So it doesn't. There's no there will be there won't be a problem since you understand the whole concept of finding the mass moment of inertia, and then you can find the center of gravity for this pendulum, because if you say as I we discussed just now, if you look at this one as a split road, eh, so the G is in the middle for road OA, and G is also in the middle for road BC. Now when you combine it, G for the pendulum is if shifted, right? Shifted. Alright. So YP is equal to the equation to find the mass so the center of gravity is the summation of Y. Okay, summation of the center of gravity for all component. For all component, you have two component here, BC and OA. Summation of the Y prime, the center of gravity in Y axis, okay, time its mass divided by summation of mass for the whole component BC and OA. If this one, if you want to find the center of gravity in Y, they are two because here given to you Y measured from here. Okay, you can do your own coordinate system. You can say this is my Y is starting from here. Okay, this is 0, Y starting from here, but in this figure it shows you you can say that you can assume that it start from here, Y starting from here. Okay, and then this is only Y. You can find also the location of G in X, and because this coordinate system X, you have X, Y, correct? The coordinate system eh, can be described in X and Y, because in the textbooks it give you only uh, the position of G in Y coordinates. So if you want to find in X, so it summation of X M times M summation of M. We do it both. We do it both. So for road OA, G is here, of course. G is here. So if Y measured from this point, from this line, downward is Y. Eh? So Y there is for road OA is in the middle, which is 0.5. 0.5 times its mass, 5 kilogram, plus for road BC, the G is here. Okay, so the distance in Y from this line, from this reference is, see that, goes to G is 1 meter. So 1 times its mass of BC is also 5 kilogram, and then divide by summation of mass for both road BC and OA, which is 5 by 5 is 10 kilogram. So let's calculate this one later on. For x, for x, eh? for x, let's take x is measured from where? Eh? You can define x is measured from, let's say this is y, x measured parallel to b, this is 0. Okay, this one x, this one y. Okay, so the location of center of gravity for OA in x, which is of course from here to here, correct? From here to here, okay, or from here to here, which is 0.5 meters, and 0.5 for road A times 5 kilogram. How about road BC? Similar. From here to here is also 0.5 meter in x. In x. So you have 0.5 times 5 divided by 5 plus 5. So the answers for this one, let's me calculate it. Okay, sorry, this one 5. This one 5. The y is the coordinate for y is 0.5. Coordinate for x is 0.5. It means that the center of gravity for this pendulum is 0.5 measured from x. Okay, 0.5 is somewhere here. Okay, and y is 0.75. Y is measured from this axis, from this reference. Y is downwards for 0.75. So your g is xy is 0. This is a coordinate for new g of the pendulum. Alright, so thank you very much. We have solved these problems. So I hope that you understand the whole how to find the mass moment of inertia and mass center of gravity. Thank you very much.